Monitoring is an essential activity to evaluate performance of a system. It aims to gather data and analyze to improve the system. Monitoring can be categorized as predictive maintenance, where performance of a system is continuously measured during its operation. It can be performed locally and/or remotely using equipment to store and transmit the data. Continuous feedback from monitoring activities is also crucial for early warning mechanism in a system, which can prevent failures and casualties. The benefits of implementing monitoring system are: first is evaluating whether electricity generation from the PV mini-grid can fulfill customers' demand. Second is understanding the system performance, including its efficiency and robustness. Third is providing support to local operator during troubleshooting when problem occurs. And fourth is providing important information for further improvement to the system design, thus the components in the system can be optimized. There are some methods to do monitoring. First, check the system manually or locally. The operator should manually check the system every day by looking at the monitoring panel on AC distribution panel and control panel. Operator should also visit the powerhouse and take notes on basic measurement, namely energy output, battery voltage, energy input from PV modules, and others. These data should be sent to the system owner routinely. Second, equip monitoring system with data logger. Data from the system is gathered based on design parameter. All the required parameters for analysis should be registered when the system is being set up, hence the data will be logged and recorded in a memory card. Please notice that the frequency of data logging will affect how much data can be recorded in a memory card. Old data will be replaced by new data when the card is full. Third, use GSM or GPRS network for monitoring system, especially for remote locations. It will give you more stable connectivity than internet data. The monitoring system collects data from the registered parameters, then send it to the cloud through the network. Later, the data is processed by the algorithm and results in predetermined indicators shown on the monitoring dashboard. The setup enables the system owner to monitor performance of their system and as an early warning system. Let us take a deeper look on what to be analyzed from PV mini-grid performance. The evaluation not only for overall performance but also dig into individual components. It aims to give clear insight for improvement or mitigation for decreasing system performance, for example battery efficiency, battery cycle behavior, and energy losses on photovoltaic modules. You can look into a study titled Performance Analysis of Photovoltaic Mini-Grid for Rural Communities in Indonesia for more details. Meanwhile, let us learn about parameters that should be incorporated in the monitoring system for DC coupling system. First, compute the performance of photovoltaic modules. It comprises of efficiency of the PV modules, production factor, and energy curtailment. Second, compute the overall performance of PV mini-grid, which consists of performance ratio, capacity factor, efficiency from the solar charge controller, and efficiency of battery inverters. Third, calculate battery performance that includes battery efficiency and state of charge of the batteries. Fourth, calculate load behavior contains load profile and demand trend of the electricity. To install remote monitoring system properly, we need to learn how it communicates and processes data. First, in general, remote monitoring system consists of monitoring device as the data center for individual components and control panel. Data collection is performed by gathering data such as voltage and current from each power electronic components, also irradiation data from pyranometer, then send it to monitoring device through communication cable. The data then visualized, stored in data logger, or transmitted to data cloud when GSM or GPRS network is available. After knowing how the good monitoring system for PV mini-grid looks like, let us continue to learn installation of monitoring system. The first thing to remember is to ensure that all the monitored components are connected to the monitoring devices. However, take note that there is a maximum number of components that can be connected to a monitoring device. Consider using additional monitoring equipment and create multi-cluster configuration when maximum connected device had exceeded the limit. Functional monitoring system has their devices connected to the measured components. For example, COM-box with ZEN-bus to connect to PV mini-grid components and RS485 to connect with pyranometer. Another example that solar charge controller and battery inverters from the same manufacturers are monitored in a communication network. Avoid using solar charge controller and battery inverters from different manufacturers. Such practice will result in communication problems between the components. Good practice is to use strain relief boot to protect cable ends and connectors. Communication network terminator needs to be installed on the monitoring device. This is the first device that is installed in the network. We can see in the examples that there is communication network that is not terminator with network. This practice will create communication problems. Notice good installation from tidy cable arrangement for monitoring device and control panel system. In the example, we can see router. Router will only be used when remote monitoring via GSM or GPRS is possible. Connect all the required components. One of the example leaves pyranometer uninstalled. Hence, the data from pyranometer cannot be read by the monitoring system. To ensure good data collection, communication cable must be installed properly. So we will discuss things to be considered when installing communication cables for monitoring system. Use high-quality Ethernet cables with strain relief boot to avoid pressure to the conductor. The pressure can cause network failure. There are various types of straight-through cable which is often used to connect devices with different types. Please do revert to manual book from the manufacturers to know the recommended cable type. When the network is connected through the AC chain, network terminator should be available at both ends. There are some examples from pyranometer installation. The first picture shows that pyranometer is connected to monitoring devices using RS485 interface. The second picture shows that pyranometer is installed but not connected to the monitoring device. This will cause data from pyranometer will not be logged. Another example exhibits pyranometer that connects to Modbus RS485 terminal. The Modbus network is terminated using a 120 ohms resistor. Next example is the installation of analog input module from pyranometer, which is messy and not safe. From these examples, we should remember that it's not enough only to install pyranometer properly, but also be appropriately connected to the monitoring device. The data availability and reliability should be validated from the monitoring device. Install additional resistor with 120 ohms capacity for system without internal resistor terminator on RS485 network. What if you already have done unsafe installation? Can we fix it? Yes, there are several ways to do this. First is to connect pyranometer to monitoring device into the available input in the monitoring system. If Modbus RS485 interface is available in the monitoring device, make sure that pyranometer has the same communication protocols and interface to avoid additional data conversion modules. Next, pre-install analog input module and reroute cable. Lastly, install terminator resistor at RS485 serial network ends if it's not available in the monitoring device. From the pictures, we can see examples how pyranometer is not installed properly. In the bad examples, pyranometer is connected to additional data logger device, hence data can only be gathered and monitored in the personal computer. In another bad example, pyranometer is installed vertically under the roof. Thus, the pyranometer will be under the shade and give inaccurate and unreliable irradiation data. In the good example, pyranometer is installed on the photovoltaic panel and directly exposed to sunshine. This arrangement will give us accurate irradiation data. Now we continue to explore more about pyranometer. What should be considered when installing the pyranometer? Pyranometer should be installed on the same plane as photovoltaic modules to represent actual irradiation that is received by photovoltaic modules. Similar to photovoltaic modules, pyranometer should be free from shading from time to time. Validate irradiation data during commissioning. Data can be retrieved from memory card in the monitoring device. Glass surface of pyranometer should be regularly cleaned and free from cracks or dirt to increase light transmission into the sensor elements. Remember that by installing pyranometer on the same plane with photovoltaic modules will give accurate analysis since it is placed in identical tilt and position. We recommend to install pyranometer on top of photovoltaic module structure to avoid shading from all angles. The picture shows several examples with inappropriate installation practices for pyranometer. If the pyranometer installed on powerhouse roof, it will follow tilt from the roof, which is different from tilt angles of the photovoltaic modules. Good remote monitoring system should at least fulfill requirements such as equipped with data logging function using memory card. The logging interval is set up at least every 1 hour. It means data will be logged every 1 hour and stored in the memory card. Accessible both from personal computer or web browser. Compatible with the type and brand of the installed power electronics tools equipment and pyranometer. Compatibility means that both equipment can easily communicate with the interface and the available protocols. Geared with communication interface via Ethernet and RS485. The picture shows good examples of remote monitoring system from global renowned brands. Parameters calculated in the monitoring system depend on the PV mini-grid configuration. For DC coupling systems, the parameters are irradiation, module temperature, output voltage from photovoltaic modules, output current from photovoltaic modules, output voltage of solar charge controller, output current of solar charge controller, battery temperature, battery voltage, battery current, ambient temperature, input voltage of battery inverter, input current of battery inverter, battery charging status, output voltage of battery inverter, and output current of battery inverter. For AC coupling systems, the parameters are irradiation, module temperature, output voltage from photovoltaic modules, output current from photovoltaic modules, output voltage of grid inverter, output current of grid inverter, battery temperature, battery voltage, battery current, ambient temperature, input voltage of battery inverter, input current of battery inverter, battery charging status, output voltage of battery inverter, and output current of battery inverter. There are also parameters that are not measured directly by the components but important to be included in the monitoring system, such as module temperature and ambient temperature. The data should be measured using additional sensor and connected to monitoring device based on the available protocols or using Modbus RS485. It is important that all the required parameters are registered and included in the data storage or memory card. However, some manufacturers set limited amount of data that can be stored in the data logger. Hence, it is better to store data as a combination from several components with similar function to adjust with the limitation. Moreover, there are some ways to ensure collection of reliable data. Ensure that memory cards have been formatted and inserted into the monitoring device. The memory card capacity should be able to store data in 1 year with logging interval of 1 minute. The recommended minimum size is 2 GB. Data in the memory card should be verified during commissioning, including logging interval and its accuracy. Monitoring data for a week can be submitted as commissioning report. Simple performance analysis should be conducted during commissioning to validate data with at least weekly recorded data. This process can reduce anomaly in measurement and avoid false analysis. To evaluate this session learning and understanding, please take the quiz.